this is a series that I wrote like half a dozen different presentations called Divinely Designed, and it's really just to help people have a better appreciation for how amazing their body is. So this one is more specifically about the immune system, which is like staggeringly complex, but it's just that amazing. And most of you guys have been here for like the general introductory to the body turnover and all the different types of cells and the nervous system and the spine, all those good things. So we'll kind of skip through most of the basics here, but we'll hit a few of the basics just so that it's not completely like foreign. But we're going to start off with just a quick review. Remember when we're talking about health, and we're going to talk about health when we're talking about the immune system. Our definition of health, we're going to take Jordan's medical dictionary, it's a state of mental, physical, or spiritual well-being or normal function. Okay, those two words, normal function, we see repeated in Webster's dictionary. It's a state of normal function of all the parts of the body. So again, when we're talking about normal function, up at the top there, 100% function, 100% life, right? So that's normal function. Sorry. There we go. And in theory, we should be able to stay up there at that normal function, 100% function of our body, indefinitely. But there are these things that pull us off that line into that state that we talked about called dis-ease, where the breakdown in our body, the cells dying, exceeds the cells being born and taking their place, okay? So there's more cells breaking down than there are cells building up in that state of dis-ease. If left unchecked, we go down the downward spiral until it becomes a full-blown disease. We're usually seeing symptoms down there, which are an effect of, that cause. And if it's left unchecked, eventually we get that 0% function, 0% life, we're dead, okay? So, we're talking about the things that could pull us off that line of ease, and the germ theorists would say one thing that could pull us off that line and make us sick, drag us down into that disease, would be bugs, like viruses, bacteria, different pathogens. So we're going to talk about the germ theory of disease, which actually starts with Koch's postulates, okay? This we probably all studied in high school, if you remember this, the germ theory. You don't remember this? Okay. So Koch's postulate basically says that if you find a sick animal or a sick person, you should be able to identify that pathogen within them. You should be able to put it on a plate, an agar plate, and grow it, and then you should be able to take that and inject it into Koch's postulate says a susceptible host, okay? But most germ theorists will say anybody, they'll say a healthy individual, and reproduce that disease, okay? You guys all follow that? So we take that diseased animal, we isolate the causal agent, whether it's a virus or a bacteria, we isolate it, grow it, and then inject it into a healthy animal or individual and reproduce the disease. Okay, that's the germ theory of disease. But Koch's postulate doesn't say a healthy individual. It says a susceptible individual. So remember that word. That's the key word, susceptible. Okay? Because people just assume that we're taking that from a dead rat and injecting it into a healthy rat. It's Louis Pasteur and Claude Bernard were two opposing sides of this argument back in, I think this was 1500s or something. So they're looking at, Louis Pasteur said it's the seed, not the soil. He said it's the bug, not the environment, internal environment of the host. It's the bug that I give them that makes them sick. Whereas Claude Bernard said, no, it's the internal, susceptibility or resistance of that host that determines whether they get sick or not. Okay, so we want to look at, again, we talked about this, when are you sick and when are you functioning normally, all right? So when we're talking about sick, we're not necessarily talking about things on this list, because things on this list we can see as normal functions of the human body. Like if we eat some potato salad that's rotten, and our body can recognize that we just ate a poison, what would a normal, healthy body do? It would get rid of it, okay? Out one end or out the other, okay? So, vomiting or diarrhea. Either way, it's getting rid of that toxin, which if we don't get rid of it, we're probably going to die, okay? More than likely, we're going to end up in the emergency room getting our stomach pumped before that happens. But those are normal functions of a healthy individual that gets exposed to a poison in their stomach. And the same thing is true of most of these, like a cough we talked about. If you get dust in your lungs or particulate of whatever kind, a normal healthy individual can identify that that's not supposed to be there, and the way to deal with it is to cough, and that's just a normal function. Same thing with a fever. We talked about that fever study, okay, and we said, we're not saying let a fever run up to 120 degrees and don't do anything about it, because a high spiking fever that shoots up real high real fast, that's a medical emergency. But thank God we've got a place for you to go for that, called the emergency room. But most of our fevers, we found out, are not going to be that. They're going to be that 101, 102, 103 maybe. It's still high, but not life-threatening. What they found in that fever study over a 2-year period of time, Harvard did this study on fevers where you come in and fill out your intake form. If one of the things that you listed on your symptom survey was that you had a fever, you're asked, do you want to participate in our study? If you said yes, you're going to get either a placebo or you're going to get Tylenol every 4 hours. Now, we know that Tylenol reduces a fever, but that wasn't what they were studying. They were studying what percent of the time is that necessary or is it a good idea. And what they found was the placebo group got better on average 3 to 4 days sooner than the Tylenol group. And we thought about that for a while, and we're like, okay, so if a normal healthy individual, does a fever have a purpose? It's going to burn off the bug, because most of those bacteria and viruses are temperature specific, right? So you raise that temperature up a degree or two, or even lower it a degree or two from their normal environment, and it's going to kill them. Or they just can't reproduce as fast, and then the immune system comes in and kicks their butt, and it's over. So 90% of the fevers broke within 24 hours, 99% broke within 48 hours, left 1%, and that 1% they did need medical intervention. But a couple of things to remember here. The things that we're talking about is 99% of your fevers are a normal function, okay? And the recovery there, that the placebo group got better 3 to 4 days sooner, that fever is one of the first lines of defense. If we bypass that by giving them a Tylenol and bringing them down to a nice cozy level for me and the bug, right? You bring that down, it takes 3 to 4 days for the body to mount what's called the cell-mediated response. We're going to talk about different parts of the immune system, okay? But I wanted to bring up this study because, again, it was another Harvard study, but it mentions or it highlights the susceptibility, okay, that we're talking about. So Harvard did this study where they actually took volunteers and they would implant the rhinovirus, which the common cold virus, directly in the nasal mucosa of the volunteers. So if we, using Koch's postulates, the germ theory, we identified this sick individual, we took that, isolated that virus, threw it up on a plate, took it on a cotton swab, and literally implanted it into your nose, okay? Disgusting, yes. But they volunteered, they probably got paid for it. We would expect that if the germ theory were 100% correct, that 100% of the people that have that virus directly implanted in their nose mucosa would get the common cold, right? But what percent actually got it? 12%. Only 12% actually got the cold, okay? So the other 88%, they're not susceptible. That 12%, they're compromised somehow, and they're susceptible. So again, it's not taking that virus, in this case, implanting it into a healthy individual and making them sick. 88% were the healthy ones in this case. Those 12% were somehow compromised, okay? So we're going to talk about those compromises, but don't make assumptions like 100% infection rate or something like that when we're talking about really any given bug, okay? So what is the immune system? Well, it's a complex network of cells and proteins that defend the body against infection. And then it, of course, keeps record of all the germs or microbes that we've ever defeated. And when we get exposed to it again, it recognizes it and it destroys those quicker. So here's the body's different lines of defense, okay? And the first line of defense is actually just barriers, like our skin is a barrier to bugs coming in and infecting our inside. Wherever we don't have skin, like inside our mouth, inside our nose, the lining of our lungs, airways, there's mucous membranes, okay? Lining of your stomach, all those things have mucous membranes. And on those membranes, there are certain proteins and there are certain receptors, okay? And a receptor is a specialized kind of nerve that it has binding sites that something might bind to it for a short time and then break off and go floating away. But when it binds to that receptor, that fires information up to the brain to let the brain know that there's been an invader there, okay? And then the brain starts a whole series of chemical cascades to cause that fever, okay? To increase mucus secretion. That's how it happens even before the increased temperature. But there's this whole list of steps that happens when that receptor fires that information up to the brain saying, okay, this bug got past the first line of defense. Where's the second line of defense? Okay, here comes that fever. That's a chemical cascade that starts. Remember, 3 to 4 days later, that's when the cell-mediated response, so the brain fires information to the thymus gland, which produces white blood cells and says, okay, we got invaders here, start producing more white blood cells. So then those white blood cells, they're bouncing around inside the blood vessels. And remember, on the surface of those blood vessels, there are these nerves, receptors, that those cells will bounce by, connect to, get information about the position or location of that infection, and then bounce off and make their way down to that infection. Okay, it's that complex. We didn't even know about this until probably the late 90s, but that sparked an entire field of study called neuroimmunology, and it's just how the nervous system and the immune system co-act and relate. So then the next layer of the immune system, of course, is when those cells come in contact with that bug and they destroy it, they eat it, they break it down into parts, and then they'll make antibodies to those different parts so that next time we get exposed to that bug, we've got antibodies that will attach to it and kill it, okay? Or render it useless at least. So, the different components of the immune system, the innate immune system, and that's what we're talking about, those cells, and then the adaptive immune system, that's the memory, okay? So that's those antibodies that are going to be generated that are then, the code is kept within those certain memory cells, memory T cells and B cells, so that the next time that bug comes in, they generate those antibodies right away. As soon as the signal goes out saying this bug has breached, layer 1 or layer 2, now we're going to produce those antibodies a lot quicker that second time. Okay, so there we've got all the different parts of the immune system, and that a little, that was a direct quote by a world-renowned immunologist, but I want to look at that a little differently. I'm not saying that you can increase your immune system by 200 to 300% by giving the right raw materials. I'm saying if we're at 100% function, we're a normal, healthy individual, and we're eating and drinking the things that we should, okay, we're not deficient. I'm going to say if you're not getting those things that you should, we're going to be 2 to 3 times less productive, okay? So the normal in his mind is down here. We're giving you this and this and this to get you up here. In my mind, this is what you were created to be. This is the normal. This is the gold standard, okay? So we're getting what we're supposed to be getting. Our body's going to function the way it's supposed to function. So the susceptible clause, that's where Claude Bernard understood that there's a bell curve here, okay? Everything's going to fall into that bell curve in terms of susceptibility. So whenever a pandemic comes through, you're going to see that over time, that bell curve is going to play out. So what the bell curve tells us is that on this end, you know, well, let's say in the middle, that's that 80% that are going to fall as healthy individuals, okay? On one end of the spectrum, there's like the ultra healthy that they're not even going to get touched by it. They're not even going to get, you know, have any reaction to it whatsoever. Maybe they're already immune to it, but then on the other end here is that 2% and over. That 2% are the ones that are going to get sick, and they're going to require some medical attention or intervention, okay? And then of that 2%, that 0.1%, usually those are the ones that are not going to make it, okay? They're highly susceptible or compromised in some way, okay? So remember, Claude Bernard, he's the guy who said it's the soil, it's the internal environment, not the bug. Because you can take a bug, you can put it into a perfectly healthy individual, and they're not going to get sick. Okay, that 88% of those are going to fight that off. So what are the causes of that susceptibility? That's what we want to take a look at tonight, okay? So we're talking about, okay, giving your body the right raw materials to make those cells and make those neurotransmitters and make all the different hormones and make all the different antibodies and internal things that it needs to signal receptors and things like that. So nutritional deficiencies, that would be one cause of susceptibility. Like if you don't have enough vitamin C, you're probably going to get scurvy or something like that, right? So there are well-known deficiencies and then, bugs or whatever that are going to attack you and overcome that immune system. But there are some lesser known ones too. But we're going to talk about some of those. So the main causes of susceptibility would be those nutritional deficiencies. Then we've got functional deficiencies, and I grouped subluxation in there. We've talked a little bit about subluxation. We're talking about a bone out of place, putting pressure on a nerve. And remember, those blood cells have direct access to the nervous system. There's nerve receptors all along the length of those blood cells. So when those white cells are bouncing around inside those blood vessels, they're attaching to those receptors for a short period of time, getting that information from the nervous system about the location of that infection, and then they're going there. So if we have a subluxation, we're choking off that information to that portion of the tube, the blood vessels. We've reduced the effectiveness, I guess, of the immune system slightly, okay, just by taking that down. So now they have to go further down the line to get that information. Okay, they'll get it eventually. But for every subluxation we have, it probably decreases that effectiveness by a certain percentage. Okay, so I lump subluxation into those functional deficiencies, but different types of stress and trauma will also impact the immune system. And then we have genetic deficiencies, which it accounts for less than 1% of the actual deficiencies there, so we're not going to go into great detail, but I'm just going to note that that is one possible cause of susceptibility, something genetic, okay? drug deficiency? No. A nutritional deficiency doesn't mean a drug deficiency. So, kind of like when we're talking about a fever, is a fever caused by your body's deficiency in Tylenol? No. We talked about it being a normal function, but if we give a person a Tylenol that's been shown to reduce the fever, did we just increase their function or decrease their function? We decrease their function. So some of the things that we've been trained to do since we were kids actually decreases our function. It might take the body 3 to 4 days longer to fight off that bug as opposed to just doing nothing, right? So we're not talking about drug deficiencies. We're talking about vitamin and mineral deficiencies. And we've got basically 3 pages, small print. I'm not going to read through them all, but each one of those is a study that shows basically we've got the soil is being depleted. Okay, you've heard that before. And basically the vitamins and minerals that were found, 50 years ago in an orange, we're down to like 25% of that. So either we're going to have to eat 4 times more of everything, or we're probably going to have to supplement. That's basically what it comes down to, is that we're probably going to have to supplement. It's not taking a vitamin or mineral as our whole, meal. It's supplementing, because, okay, we're still eating all the right foods, but we're acknowledging that some of those foods don't have as much of the vitamin C or the essential fatty acids as they used to, and as we probably need. So we're supplementing those things, okay? It's not meant to be your entire diet. It's not meant to replace something. It's a supplement. It's adding to it, okay? So neuroimmunology, again, that's what we're talking about, the field that shows that the nervous system and the immune system are actually connected. We thought for a while that they were actually separate, but they're not. That's basically one system. So those functional deficiencies happen between the brain and the immune system. Okay, so the message comes from the brain down the spinal cord, out those nerves, and then it goes to all those different organs and some of those glands that actually produce our immune cells and our immune system. Okay, but it also goes out to, like I said, those blood vessels. And as their white cells are bouncing down the tube of the blood vessel, they're getting that information from the nervous system. Okay, so the nervous system is directly linked to the immune system. So that's why, like I said, subluxation, meaning that bone that's out of place in her spine, putting pressure on that nerve, will reduce the immune response, and it will reduce the efficiency of the immune system. And we found out last time that subluxation can reduce that nerve's function by up to 60%, okay, right off the bat. And it's something that usually gets worse with time. So, a couple studies that linked the nervous system and the immune system in a way that we did not expect. How many of you guys have heard of Masha and Dasha? No? Okay. So they were Russian twins born in 1950 in Soviet Russia. They were taken from their mother at birth, and mom was told that they died, and they were experimented on until age 17, at which time they both said, no, you can kill us, we're not gonna be your lab rats anymore. And then they were released. But they had, we would call them Siamese twins, but not white, right? So they had separate nervous systems, separate central nervous systems. So separate spine, obviously separate brain, but they shared blood. So they shared an immune system. All the same blood, all the same immune cells. But what they found was Masha, so the crooked spine of the two, Masha would get sick and was ill very often. Whereas Dasha, the gal with the straighter spine, she wasn't. Okay? Masha actually developed measles, again, sharing the same blood, the same immune system. Dasha didn't get measles. So that half of the body, she didn't have any spots. This half over here, she's got a fever, she's got spots, she's got all the symptoms, whereas Dasha didn't. And Masha also got influenza, and Dasha occasions, these girls sharing the same bloodstream and the same immune system, but different nervous systems, their immune system reacted differently, okay? So that, in a way, kind of goes back to a chiropractic lesson here, all right? That subluxation in Masha's case is causing a decrease in her ability to fight infections. And then we have the Spanish flu of 1918. This is a piece of chiropractic history because this is actually how chiropractors got licensed in Minnesota and Iowa and Kansas, I believe. But anywho, during the influenza epidemic, if we looked at Iowa, for example, Iowa was the birthplace of chiropractic. So Iowa had, in 1896 already, they had like the first chiropractic hospital, okay? And everybody that came in there would be diagnosed medically by medical doctors, but then they would be treated chiropractically, okay? And what they found during the influenza epidemic was that in Iowa, they had 93,000 cases of influenza, and on the medical side, when they were treated medically, 1 out of 15 people died, okay? But when they were treated chiropractically, only 1 out of 789 people died. And they looked at these stats, and they said, we got to license these guys to help fight the influenza epidemic. So they actually licensed chiropractors in the upper Midwest specifically to help people with influenza because they found out that they recover better, that their immune systems work better without subluxation, which is what a chiropractor does, right? So we're breaking it down, most basic, common sense stuff, eat right, drink right, breathe right, move right, okay? All things that we can do to increase our immune system. Eat right, okay, we know that we probably can't just eat well. There are things that we probably have to eat that we're not going to get from our food, all right? Like supplementing vitamins and minerals. I would recommend whole food vitamins and minerals. But there are things that we're probably eating that will reduce our immune system's capacity as well. What are some of those things? Sugar has been shown to reduce immune response, increase inflammation, okay? So we know that nothing fun. Drink right, same thing. Sugary sodas, sugary drinks, even sports drinks, because they say sports, everybody just assumes that they're healthy. But if it's 70 grams of sugar, again, that's probably going to give you issues with your immune system, inflammation, and immune response. Breathe right, basically don't smoke, right? But also, breathe right includes exercising and getting that deep breathing done, because if we're sitting at our computer all day long, shallow breathing, there is something called acidosis in your body, just naturally because of the breakdown of different things in your body becomes more acidic and more susceptible to those bacteria and viruses, okay? So breathing deep, like we do when we're exercising, actually helps balance the pH of our blood and our system, and helps keep us from being susceptible, okay? So that's breathe right. Move right, again, that would include things like exercise to help us breathe, but also exercise in many different studies has been shown to increase your body's ability to fight off disease. But move right, I would include in that chiropractic, getting those subluxations checked and adjusted, because then if the body and the spine is moving right, that would mean no subluxation there, and then of course the information's getting out to all the different parts of the body, including the immune cells and the immune system, and it's working the way it should, okay? So, with that, how'd I do on time? I usually try and...
Got 3 minutes to go.
I usually try to keep it to a half an hour, okay? So, I'm gonna stop there, but I will just say, we do these presentations in series. Next week, the series is called Above the Atlas, and that's actually not even technically chiropractic. It's things about mindset that we can do to help ourselves get past, sticking points, get past maybe physical ailments and physical goals and business goals or whatever. It's above the atlas. The atlas is here, the top bone in the neck, it's above that. So it has to do with your brain and your mindset, okay? So it's more about like philosophy. I'm a PhD in philosophy, so I love to talk about philosophy. So chiropractic philosophy, but just philosophy in general. So that's next week, is actually the series above the atlas. With that, everybody who shows up or watches us online, you get a free exam, x-rays, and 2 free adjustments just for showing up or watching us online. So with that, thanks for watching, thanks for coming, have a great evening.